In this video, we're going to continue talking about Taylor series. So we're given this function e to the 2x power, and it's centered about a equal to 0. And we have three questions we would like to address. First, we would like to find the first four terms of the Taylor series. Second, we're going to rewrite the series using our summation notation so that it's concise. And the third thing we'll do is look at the interval of convergence of this series. So in order to calculate our terms of our Taylor series, we need to look at the function and its derivative. Well, our function is e to the 2x. And the first derivative, using the chain rule, is 2 times e to the 2x. And if we were to take the second derivative, continue to use the chain rule, 4e to the 2x, and so on. Now, since we're centered about 0, we're going to need to find the value of the function at 0. So if we plug 0 into our function here, we would have 1. E to the 0 power is 1. And if we were to plug in 0 into our first derivative, because of the coefficient of 2, we'll have 2. And then likewise, plugging 0 into our second derivative, we end up with 4. And we're looking for patterns here, and I think you probably see one of the patterns. It has something to do with the power of 2. So at the third derivative, the value at 0 is 8. But let's continue on. If we were to take the nth derivative, this will help us with part B of the question. If we were to take the nth derivative, then we would have 2 to the n power. We're ready to write the series. Thus, the series is given by using our Taylor series formula, we would have 1 plus 2 times x minus 0, or 2x, plus our coefficient of 4 times x squared over 2 factorial. And let's be careful here not to simplify too soon, because the process might lead to a nice summation formula. And then we would have 8 times x cubed over 3 factorial. So hopefully you're seeing lots of patterns here. And to finish off part A, or that's probably the best way to leave part A, but to continue to see the pattern, we could rewrite 1 as 1 over 0 factorial. Not that we would want to do that, but we might need to in order to see the pattern. And we could rewrite 2x as 2x over 1 factorial. And the others are all set up nice and neat for us to see this pattern here. So we're all ready for part B. So hopefully in part B you can see that we're starting with 0 factorial. So as we're counting, we'll originally let k be 0, and it will march on off to infinity. In the denominator, that's where we have our k factorial. And in the numerator, we can see we have 2x, and then we have 2x squared. So 2x to the kth power. And so there is our summation formula that we might not have worked too much since Calculus 1. And then finally, we're looking at the interval of convergence. So we will use the ratio test here, and we'll look at the limit as k goes to infinity of 2 successive terms. And I'll let you work on the calculations here and ask questions on the discussion board. But you should find out that this results in 2 times x over k, which is equaling 0, which means that our interval of convergence is everywhere, from negative infinity to positive infinity. Right, as mentioned, I'll look for any questions that you might have on the discussion board.